OS 2200 QProcessor, Disaster Recovery Operations. Let's take a look once more at what the replicated systems look like. They are two totally separate AM LANs with duplicated QProcessors, OS 2200 partitions, and operation servers. Now let's take a look at disaster recovery operations. So this assumes that both cluster pairs in the primary and the secondary systems have been set up and configured identically. When the HA cluster pair is not being used on one side or the other, the HA cluster is in the standby state. This means that all resources are stopped, but the cluster can still heartbeat the other node. The primary system is backed up to the OS 2200 storage using the DR backup profile. The DR backup profile gathers just the files it needs for disaster recovery operations. It also has some post-backup operations which puts the cluster in the correct state so that you can easily get back to your primary system when needed. Again, this assumes that both the primary and the secondary systems have access to the OS 2200 storage so that both systems can reach the backup archive. When you want to switch between your primary and secondary system for disaster recovery, you first stop the WMQ 2200 operations. Next, if you're using external clients, we recommend that you stop the public access resources in the HA cluster so that all external clients can no longer reach the QProcessor. After that, you can issue the DR backup, which will store the resulting archive on the OS 2200. This will gather the latest changes you have made to either the cluster definitions or the important files, the MQSINI and others on the primary systems. After the backup is run, it will stop all HA cluster resources on both nodes and put the HA cluster in standby. At this point, once all the resources are quiesced, you can power down all the primary systems. The next step is to make your 2200 disks available to the backup system. I'm going to show you how to prepare your primary cluster for DR operations. Here we are in the Manage HA module, and as you see, all our resources are up and running. This would be our primary cluster. The first thing you do is shut down your WMQ 2200 subsystem, and this stops all client accesses coming to this QProcessor cluster. The next thing, if you have external clients, you'll want to stop the public access. This will stop access to the HA cluster from the public interface. Once this is done, we can now take our DR backup using the File System Backup module. The File System Backup module comes with a backup profile called DR. At this point, we can take a look. This includes all the necessary files needed to run your cluster, any files that might have been updated since the last time you switched. You'll want to take the backup to a 2200 system or pack that can be reached by your DR pair. You want to make sure you set the file qualifier to something that you'll remember so you can see them on your backup pair. So this is going to take create an archive with all the necessary files, and then it's going to put the cluster into standby. Now, just because it says it's in standby doesn't mean it's complete. All the resources have to stop and quiesce, and this will vary depending on how many resources you have and how long it takes to stop everything. Once all the nodes are stopped, then you can shut down the system and restore the profile to the other system. Here is the secondary system's action when switching for disaster recovery. The first thing you'd want to do is boot your OS 2200 partition. After the 2200 has successfully started, you would want to start your OS 2200 QProcessors. The cluster service will be running, but the nodes will be in the standby state, which means all HA resources at this point will be stopped. The next thing you'll want to do is issue the restore of the previously taken DR backup profile, which is located on your OS 2200 storage or movable pack. This will copy any updates you made to the HA cluster definition, as well as any updates made to critical OS 2200 QProcessor files. This includes any updates you might have made to MQS-INI. Then you can bring the HA cluster nodes online after all resources have successfully started. Then you'll want to start the WMQ 2200 subsystem. Now you're ready for operations. Now I'm going to show you how to restore a cluster pair from a DR backup. We'll notice once we power on the system that both cluster nodes are in the standby state as we had last left them. They'll be in standby, all the resources should be red X and stopped. So you'll want to navigate to the File System Backup module to prepare for your restore. You'll want to hit the restore link to get the archive from wherever you backed it up. So you want to use the file qualifier that you had last used and list the backups. This will retrieve all the archives for QPR15, and you'll see I have two DR profiles that were used. So I'll want to restore the latest one, and this will present a list of all the files. I can now look at the files if I needed to. I can view any files that I particularly was concerned about. I could restore only selected files by just unselecting and selecting from the list. In our case, we're just going to restore the whole thing. Now there's two scripts, one that is run before the restore and one that's run after. We have no real actions to run before the restore, but after the restore we're going to want to run a script similar to this Unisys supplied one, or this one in particular, that's going to start all the necessary services and bring the cluster back out of standby. You can take a look at this script, you can edit it, you can add your own scripting for your needs. We'll want to make sure we overwrite the existing files in this case and then proceed with the restore. So this will restore all the cluster files and start all the cluster services that are needed and bring everything back out of standby, which takes a few minutes for the cluster to resync. So once the files in the DR archive have been restored, you can then bring up the remaining cluster node back to the online state by simply going to the Manage HA module and clicking on the online link. This can also be scripted in your post-restore script. Notice that the public interface still stays in the stopped state, and this is because that's how we left it. So you'll need to start that manually or add that to your script as well. At this point now your system is back in operation. Here are some extra scripting commands that you could use to enhance the automation of going to DR. The first is to automatically power up or power down your system. As you can see, you can use IPMI scripts from Windows, or SMC has a GUI interface to do this action. Some other useful cluster commands that you may want to add when you're enhancing the pre and post backup or restore scripts are these two for the node. You can use from a script the command CRM node online to bring any node in the cluster back online from standby. Likewise, if you want to go into standby, you can issue the command CRM node standby with the node ID. Now both of these commands are available through the Pacemaker open source product. There are also commands that you can use to control the resources. This is CRM resource start with the resource name, and then CRM resource stop and the resource name. Now keep in mind that the start just sets the target role of the resource, and depending on the dependencies and what the state of the other resources are, this may not occur right away. The stop, it's the same thing. So any of these commands are command line commands are available to you to include in your scripts. There are more also. You can check them online with the Pacemaker product. This completes this demo.